Welcome back to the deep dive. We are doing something a little different today because the source material we have is, well, it's heavy.
It really is.
It looks like a standard technical report on the surface, maybe something you'd skim over while drinking your morning coffee.
Right.
But once you peel back the cover, it's actually an existential map of kind of where we are as a civilization.
I think that's the perfect way to put it.
Yeah.
We are looking at a piece from the source Netizen, dated January 16th, 2026. And the article itself is titled AI in Global Education, The Pain Points.
And usually, when we talk about pain points in tech, we're talking about, I don't know, UI lag, maybe subscription costs.
Sure, or a buggy API.
Exactly, an API that's difficult to integrate. But this report, it frames pain points as this massive civilizational challenge. It's not just about debugging code. It feels like it's about debugging society.
Exactly. And it opens with this incredible, almost spiritual hook. It references the age of abundance that was prophesied in, ancient scriptures. This idea of a golden age where humanity wants for nothing, where knowledge and resources are, well, infinite. And it just smashes that ancient prophecy against the gritty, messy reality of where we actually are in 2026.
The tech demo versus the real world.
Precisely. The core thesis here is fascinating, and frankly, it's a bit counterintuitive.
How so?
It argues that AI in global education isn't failing because the models aren't smart enough. We have the smarts. We have the compute. It's failing because reality is infinitely more complex than a clean Python script running in a lab in Silicon Valley.
So our mission today is to perform, I guess, a forensic examination of this failure. We're going to walk through these pain points from the dirt floor right up to the cloud.
And then look at the solution.
Right, a solution which the source argues might be the only way we learn to govern AI safely. As a species.
It's a huge claim, a really huge claim. But to understand it, we have to start at the absolute bottom. The source calls section 1 the floor problem.
Let's get into that, because I think for a lot of us, and definitely for the developers building these tools in, say, San Francisco or London, there is this baked-in assumption.
Oh, absolutely.
You open a laptop, the Wi-Fi connects, the page loads. The source calls this the Silicon Valley assumption.
Right. The assumption of always-on broadband plus modern devices. It's so ingrained in the development culture that nobody even questions it. It's just air.
Yeah.
But the report just throws cold water on that immediately. It points out that in the target demographic for global education, we're talking rural India, sub-Saharan Africa, the remote Andes, that assumption isn't just wrong, it's the primary point of failure.
So we're not talking about slow 5G or spotty 4G.
No. We are talking about 2G.
2G. Wow. I feel like most people listening haven't seen an E or 2G symbol on their phone in, a decade?
It feels like ancient history.
It does. So why is that specific technical limitation? Why is it so fatal for modern AI?
Well, it comes down to latency and packet loss. Think about how these large language models, these LLMs, actually work. They predict the next token, one by one. It's a stream of data. Okay. To make that feel like a real conversation, that stream needs to be fast. It needs to be uninterrupted. If you are on a 2G connection, you're dealing with massive latency. You ask the AI a question, and then just silence.
The spinning wheel of death.
Exactly. For 5 seconds, 10 seconds. Maybe the connection drops entirely and has to reestablish.
And pedagogically, that just kills the moment, right? The learning moment.
It completely destroys it. If a child asks a question, let's say, why is the sky blue? And there's this 20-second awkward pause, or the answer comes back in broken chunks.
It's not a conversation.
It's not a conversation anymore. It's a frustrating data transaction. The magic of the AI tutor just collapses into a frustrating exchange of packets.
And that's all assuming the power is even on.
That's the other part of the floor. Power instability is listed as a major pain point. It's so easy to forget that servers need power, but so do the client devices. The phone in your hand needs juice.
Right.
The source calls this the offline-first reality.
Right.
In many of these regions, electricity is intermittent. We're talking about load shedding, scheduled outages, or just general grid instability.
So if your entire AI education solution requires a constant connection to the cloud to run its inference,
and the power grid goes down for 4 hours in the afternoon,
school is canceled.
School is effectively canceled. The AI becomes useless.
It turns a supercomputer into a paperweight.
Instantly.
But let's say you have the power. You've got a generator running.
Yeah.
The report then highlights device scarcity. And we aren't talking about a classroom where every kid has their own iPad Pro.
Oh, Far, far from it.
Okay.
We're talking about shared devices. One outdated Android phone for a family of 6,
Wow.
or a single beat-up tablet for a classroom of 40 kids. And these aren't the latest iPhones with powerful neural engine chips inside.
No.
These are budget smartphones from 5, 6, 7 years ago. They have cracked screens, degraded batteries that don't hold a charge, and minimal RAM.
So practically speaking, you can't run the AI on the phone itself because the phone is too old. It doesn't have the compute power.
Right. No edge computing.
And you can't really run it in the cloud effectively because the internet is too slow and unreliable.
Exactly. You are trapped in the middle. The hardware can't handle the edge, and the network can't handle the cloud. It's the worst of both worlds.
And then, on top of all of that, you hit the economic barrier. The article calls it the high cost of data relative to income.
This is a metric we rarely think about in the West because we just have unlimited plans.
We just pay the monthly bill and forget it. It's like a utility, like water or electricity.
Right.
In many of these markets, data is purchased by the megabyte, often on a prepaid scratch card.
Right.
A simple text-based chat with an AI is relatively cheap, but a voice interaction, or a generated image, or a little video explaining a math concept.
That burns through data. It burns data incredibly fast. And if a parent has to choose between buying a data bundle for an AI tutor or buying rice for dinner,
There's no choice.
the choice is made for them.
That really puts it in perspective. It's not just about the technology existing, it's about the recurring cost of keeping it alive. So that's the floor. And frankly, it sounds like the floor is missing.
In many places it is.
But let's say, hypothetically, we fix that. We drop in a Starlink dish and a solar generator. The report says you immediately hit the next wall, the English trap.
This is pain point number 2, and it really challenges this idea that translation is a solved problem.
I think a lot of us do assume that. I can type almost anything into a translator app and get a pretty decent result in Spanish or Hindi instantly. Why isn't that good enough for education?
Because there is a massive difference between translation and localization, and an even bigger gap between high-resource and low-resource languages. The source calls this phenomenon linguistic invisibility.
Define that for us. What does it mean for a language to be invisible to AI?
Well, think about how these models, GPT, Claude, Llama, all of them, are trained.
Okay.
They are fed the internet, the text of the internet. And the internet is overwhelmingly English. Then Chinese, Spanish, French, a few others.
The big ones.
The big ones. When you get to languages like Swahili or specific dialects of Hindi or indigenous languages in the Amazon, the training data is incredibly sparse.
Sparse, meaning there just isn't much text available online for the AI to learn from.
Exactly. There just aren't billions of web pages and books and articles in, say, Yoruba for the model to ingest.
So the AI is essentially, what, hallucinating fluency?
That's a great way to put it.
Yeah.
It might get the literal words right, but the grammar is stiff, the tone is weird, or the cultural context is completely wrong. It sounds like a foreigner reading from a dictionary.
Worse, it sounds like a robot. It lacks the soul of the language.
It totally lacks the soul. And then you have to add the code-switching reality. This is a fascinating point the report brings up.
Code switching, what's that?
It's how people actually speak in multilingual societies. It's something that happens all over the world.
Oh, okay.
In Nairobi, you don't just speak pure English or pure Swahili.
Yeah.
You speak Sheng, which is this dynamic, fluid mix of both. In Mumbai, it's English. You weave 2 or 3 languages together in a single sentence.
Right, like I'm going to the Dukan to buy some sabzi, you want anything.
Exactly that. Standard AI models hate this. They are trained on formal, monolingual text. If you speak to them in a natural, street-level dialect that mixes languages, they just choke. They get confused.
Or, I imagine, they force the student to speak textbook language to be understood.
Which creates cognitive friction. It's
Right.
subtle, but it makes the student feel like they are the one doing something wrong because this supposedly smart machine can't understand their natural way of speaking.
It creates a barrier rather than a bridge.
Precisely. And the report mentions cultural mismatch here too, which is related but different. This isn't just about the words, it's about the concepts and metaphors.
Oh, this is the classic baseball example, right?
It's the perfect example. If the AI is trying to explain a probability concept, and it uses an analogy about a baseball game, strikes, home runs, batting averages, or, say, a snowy day,
And the student lives in a tropical region where neither of those things exists.
the explanation fails. The metaphor lands with a thud.
It's worse than useless. It's confusing.
It is. And deeper than that, it sends a signal to the student. The signal is, This tool was not made for you. This tool was made for someone else, somewhere else.
And once that trust is broken,
Engagement drops to zero. The AI becomes this alien tutor. The linguistic invisibility becomes cultural invisibility.
okay, so we have a shaky infrastructure and a massive language and culture barrier. Now we get to the actual teaching part, section 3, pedagogy. And the source has a really bold header here. AI does not equal education.
This is such a critical distinction, and it touches on what the report calls the over-scaffolding problem.
Over-scaffold.
It's a trap that ed tech falls into constantly. AI is optimized for efficiency. It wants to satisfy the user's request as quickly as possible. It wants to give you the answer.
But education is about the struggle.
Yes.
Yes.
You said it perfectly. It's the difference between lifting weights for someone and spotting them while they lift the weights.
Right. One builds muscle, the other doesn't.
Exactly. Learning happens in that productive friction. It happens when you wrestle with a concept and fail a few times. If the AI tutor just says, here's the formula, plug in these numbers, and here's the result, the student gets the right answer on the screen.
But they haven't learned math.
They've learned how to operate the bot.
The report calls this a mismatch between performance and learning.
Yes, performance is, did I get the question right now? Learning is, can I solve a similar problem next week without any help?
And the risk is that AI boosts short-term performance.
Not massively.
But it can actually hurt long-term learning by creating this dependency.
It becomes a crutch.
And there's also a clash with local teaching styles, right? We can't just assume every classroom in the world works like a progressive Montessori school.
A huge clash, an absolutely huge one. In many developing nations, the school system is, for better or worse, rote-based. Memorization, repetition.
The teacher as the source of truth.
Right. The teacher is the authority who broadcasts information, and the students are the receivers. Modern AI, especially the Socratic kind, is often built on Western inquiry-based learning, ask questions, explore, challenge the premise.
So you drop a Socrates-style AI, which just keeps asking, why do you think that is, into a traditional rote memorization classroom.
And nobody knows what to do with it.
Hmm.
The teacher might see it as disruptive or even disrespectful to the established hierarchy, and the students don't know how to prompt it because they've literally never been encouraged to ask why.
It's oil and water.
Complete oil and water. And that brings us to the humans in the room, the teachers. The report calls this the human bottleneck.
And I want to be clear, this isn't blaming the teachers. It seems like the report is actually very sympathetic to their position.
It is, very. It frames it as an empathy gap on the part of the tech designers. Imagine you are a teacher in a rural school. You have 60 kids in a classroom that was built for 30.
Okay.
You have very few resources, maybe not even enough textbooks for everyone. You are underpaid, overworked, and suddenly some official from the government drops a tablet on your desk and says, here, use this AI.
And your very first thought is probably, is this thing going to take my job?
Fear of replacement is very real. But even before that, even more immediate is the capacity issue. The report notes that these teachers are already at 110% capacity. They are surviving, not thriving.
They don't have time.
They have no time.
Yeah.
Learning a complex new software tool, figuring out its quirks, integrating it into a lesson plan that takes time and energy they simply do not have.
So if the AI isn't dead simple and intuitive, if it requires a login and a dashboard and a 3-hour training course, it just won't get used.
It stays in the box. I've seen this happen in the field. Entire shipments of laptops or tablets sitting in plastic wrap for years because the teachers were never given the time, the training, or frankly, the reason to learn them.
The report highlights a literacy gap here.
Yes, a literacy gap between the policymakers in the capital city who buy the tech and the teachers in the remote village who are expected to use it.
So the policymaker sees a flashy press release and a good photo op.
And the teacher sees one more burden, one more thing they have to do in an impossible day.
Wow.
And the key insight here, the thing that tech companies miss over and over, is that if the teacher doesn't trust the system, it never reaches the students. You cannot bypass the teacher. The teacher is the gateway.
Okay, let's zoom out a bit. We've looked at the classroom dynamics. Now let's look at the system itself, the bureaucracy. Section 4 covers what the article calls systemic friction.
This is where the beautiful, elegant dream of AI often collides with the slow, grinding machinery of government.
Right.
The report talks about the system of record conflict.
What does that mean in this context, the system of record?
The system of record is the exam. It's the credential. It's the diploma. At a national level, education systems are basically engines that produce credentials. That is their currency.
Their main output.
It's their main output. AI, on the other hand, is an engine that produces personalized learning. And those two goals, they are very often not aligned.
How so? Give me an example.
Okay, so the national exam might ask for a specific memorized fact from the government-approved 1990 textbook. But the AI, being up to date, teaches the student the modern, nuanced understanding of that same concept.
So the student learns more, but
But they get the exam question wrong. Or the AI teaches you critical thinking and problem-solving skills, but the exam is just 100 multiple-choice questions asking for a definition.
so if the AI teaches the student something that isn't on the standardized test, the system actually views that as a failure.
Or at least a distraction from the main goal, which is passing the test.
And then you have the cheating paradox, which is a conversation we're having everywhere, not just in global education.
But in a systemic context, it's potentially fatal. If students can use AI to do all their homework and pass all their exams, how do you credit them? How does the Ministry of Education verify that the student actually knows the material?
Yeah, and if they can't.
If they can't, the value of the diploma crashes. It becomes meaningless. So the whole system panics and does the simplest thing.
Ban the tool.
Ban the tool. Because it breaks their measuring stick.
It's so much easier to ban the new tool than it is to redesign the old measuring stick.
Infinitely easier. Redesign national assessments can take a decade of political and logistical work. Banning ChatGPT takes a single memo.
And speaking of decades, the speed of government procurement is, well, it's not known for being fast.
Slow systems, fast
No.
tech. That's the exact phrase the report uses, and it's perfect.
Yeah.
It can take a Ministry of Education, say, 2 years to run a proper process, to tender a contract, vet all the vendors, do the security checks, navigate the politics, and finally sign the deal.
And in 2 years in AI?
It's a lifetime. AI goes through 4 or 5 major generations. The state-of-the-art changes completely.
So by the time the tablets with cutting-edge AI actually arrive in the schools, the software is already obsolete.
It's a complete mismatch of tempos. The report uses the analogy of trying to dock a speedboat onto a slowly moving glacier. It just doesn't work.
And what about the money? We have to talk about the economics of these large-scale projects.
This, for me, is one of the saddest parts of the report. It's a section on pilot purgatory.
I've heard this term before. It's the idea that everything works in a pilot program, but almost nothing ever scales up.
It's a structural failure of how we fund development work. An NGO or maybe a big tech company gets a grant for a couple of $1 million. They go into, say, 50 schools. They pump in resources. They bring in trainers. They pay for the best devices. They cover all the data credits for the students. And, surprise, the results are amazing.
Of course.
Everyone claps. Glowing reports are written. There are great photos for the annual report.
And then the grant money runs out?
And the whole thing collapses. The unit economics were never sustainable. The local schools can't possibly afford the high inference costs, the per-query cost of asking the AI questions every single day.
And the NGO has moved on?
The NGO has moved on to the next innovative project because donors, they like funding novelty. They don't like paying for long-term maintenance.
So the lights go out?
The lights go out. The tablets break and don't get fixed. The data plans expire.
Yeah.
And the school goes back to the chalkboard, but now they're perhaps a little more cynical than they were before.
That is deeply depressing. But it's such a necessary reality check.
Mm-hmm.
And it leads us into what the report calls the last mile issues, things like trust, culture, and data.
Right. We touched on this with the teachers, but it goes much deeper. Let's talk about data sovereignty.
This is a huge geopolitical issue now.
It is. If you are the Minister of Education in, say, Indonesia or Brazil or Nigeria, do you really want your entire student population's learning data, all their questions, their mistakes, their progress flowing through servers in California?
Probably not. That's a lot of strategic leverage to give up to another country or another company.
It's a question of legitimacy. Who owns this data?
Mm-hmm.
Is it being used to train the next generation of the model? Is it being sold or shared? There are huge consent challenges, especially when you're dealing with minors.
And parents must be worried.
If parents feel their children are being surveilled or that their culture is being eroded by a Western AI that teaches Western values and examples,
We'll reject it.
they'll pull their kids out. They will resist. The report calls this the moment where technology meets tradition.
And there's another point in here about access that's really subtle but powerful, the
Yeah.
gender gap.
Yes. This is one of those invisible pain points that can completely undermine a project. In many households in the target demographic, the phone doesn't belong to the family. It belongs to the father. or the male head of household.
So access isn't equal even inside the home.
Not at all. If there's one device and limited data or battery, the son will usually get priority for his schoolwork over the daughter.
Wow.
So you could build the most egalitarian, unbiased AI tutor in the world, but if the physical access to that tool is filtered through a pre-existing patriarchal social structure,
The girls still get left behind.
Yeah.
You're accidentally reinforcing the exact inequality you were hoping to solve.
precisely. It's a layer of complexity you just can't code your way out of. You have to design for it socially from the very beginning.
It's an incredible stack of problems. We've got infrastructure, language, pedagogy, bureaucracy, trust, culture. The report synthesizes all of this into what it calls the raising the floor paradox.
This is the meta-insight of the whole first half of the article.
What is the paradox exactly?
It says that cutting-edge AI is built at the frontier. It's developed at the absolute leading edge of what is technologically possible. It's built on these massive H100 clusters, optimized for the fastest networks and the most powerful devices.
Right, for the frontier.
But global education doesn't need the frontier. It needs the floor. It needs boring, robust, resilient, offline-first systems.
But the incentives in the tech world, they're all about the frontier.
Completely. You get promoted at Google or OpenAI for shipping the new multimodal agent that can sing and paint and write code.
You don't get promoted for optimizing a text compressor so it works a little better over a 2G network on a $10 phone.
No one's going to get a Nobel Prize for that.
Yeah.
So the incentives of the market are fundamentally misaligned with the needs of the population.
The irony being that the communities that have the most to gain from AI, the unbanked, the illiterate, the disconnected, are the very hardest to serve because the market just doesn't reward serving them.
That's the paradox.
So is that it? Is the conclusion just, it's too hard, the incentives are wrong, let's all go home?
No. And this is where the source completely pivots. It's a fantastic turn. It says, okay, we've mapped the terrain. It's hostile. The mountains are high. The rivers are wide. So how do we cross them? And it proposes a solution it calls the trifecta.
I love this section because it's not just one simple silver bullet. It's 3 big coordinated moves. And the key is that they have to happen together.
They're interdependent.
Let's break them down. Move number 1. Conversational AI in 100 languages.
And the key emphasis here is on voice.
Why voice specifically? Why not just better text translation?
Because voice bypasses the literacy barrier. If you can only interact with an AI by typing and reading, you are immediately excluding the hundreds of millions of adults and children who cannot read or write fluently, or who can read, but very slowly and with great difficulty.
So if the AI can speak and listen, truly converse,
It opens the door to first-generation learners and to entire oral cultures. It's a much more natural interface.
it changes the whole interaction from using a computer to having a conversation. It feels more human.
Exactly. And the goal has to be ambitious, 100 languages, not just the top 10. This is how you ensure that the AI feels like a local tool, not a colonial imposition. It needs to speak fluent Marathi, Yoruba, Zulu, Bengali, Quechua.
Right. Not just translated, but fluent.
That's the key.
Okay, that's move 1. Move number 2, free satellite internet.
This one attacks the infrastructure floor head on. The report makes a really pragmatic argument. It says that laying fiber optic cables to every village in the Congo or the Amazon or the Himalayas, they'll take 50 years. It's too slow and far too expensive.
So we have to look to the sky.
We have to. Low Earth orbit satellites, Starlink, Amazon Kuiper, and others that are coming online.
But those services are expensive.
They are. So the proposal is a massive coordinated subsidy model. A consortium of governments, tech, philanthropy, and the companies themselves would essentially buy a baseline tier of connectivity for the 100 poorest countries.
So not high-speed gaming internet?
No, not 4K streaming, but educational internet.
Yeah.
Enough bandwidth to support high-quality voice streams for the AI tutors.
It's reframing connectivity as a basic human right.
It's framing connectivity as possibility. It brings the world's knowledge layer to places that have been information dark for centuries. It lets the AI run efficiently in the cloud and stream the voice data down to a device in the village.
And that brings us to the device. Move number 3. This one is my favorite because it feels so tangible. The sub-$10 smartphone.
The hardware fix. The final piece of the puzzle.
Is a $10 smartphone even possible? I mean, a cup of coffee can cost $5.
It is, the report argues, if you strip it down to its absolute essentials for this one purpose.
Okay, so what does that look like?
Think about what it doesn't need. It doesn't need a 4K OLED screen. It doesn't need a triple lens camera system for Instagram. It doesn't need a fancy glass back that shatters when you drop it. It doesn't need to run Fortnite or TikTok.
It just needs to run the tutor.
It needs a battery that lasts for a week, not a day. It needs a very good speaker and a very good microphone. It needs a modern 4G or 5G chip to connect to the satellite network. And crucially, it needs to be offline first capable.
So it can cache lessons when the internet is up and then play them back when the connection drops.
Yeah, exactly. It's a dedicated learning portal. The report calls it a book of the future.
And for an illiterate adult, that device is a lifeline.
This is where the vision expands. The report emphasizes education beyond children. Imagine a market vendor, an adult who never had the chance to learn to read.
Okay.
They can talk to this phone. They can ask about market prices in the next town. They can learn basic math to run their business better. They can learn about health and hygiene for their family. It offers, and I love this phrase, dignity without bureaucracy.
No forms to fill out. No having to go to a class and admit you can't read to a government official. It's just you and the tool, learning in private.
That is utterly transformative. That is the trifecta: voice, satellite, and device. If you can deliver all three, you don't just patch the floor. You raise the entire floor for 1 billion people.
But here's the curveball. Because you'd think the report would end there, on that technical solution. But it doesn't. It shifts gears completely into what it calls a strategic moral argument.
This is the leap.
It argues that global education is the one, maybe the only, domain where the big AI labs, OpenAI, Google, Anthropic, Meta, must collaborate.
This is the shared ground argument. And it's really powerful when you think about it. In almost every other area, AI is a zero-sum game.
What do you mean?
If Google wins the future of search, Microsoft loses. If OpenAI dominates enterprise coding assistance, someone else loses market share. It's a commercial war.
Right.
But in global education, if a child in Kenya learns to read using a tool co-developed by everyone, who loses?
Nobody.
Nobody loses. Google doesn't lose. OpenAI doesn't lose. It's a purely positive-sum game. A more educated, more prosperous world is a bigger market for every single tech company.
So the report is saying, use this unique shared ground to practice the muscle of cooperation.
Exactly. And they use a very specific phrase: collaboration without collusion.
A crucial distinction.
It's the most crucial distinction. They are not saying, hey, share your secret model weights. They're not saying, give away your proprietary IP. That would be collusion.
So what are they saying to share?
They are saying, share the guardrails, share the safety research, develop open evaluation frameworks together to see what actually works in the classroom, pool your resources to build the high-quality data sets for those low-resource languages, because no single company can afford to do it alone. That becomes a technical public good.
Okay, that makes sense. But why does this matter for the rest of us, for the bigger picture of AI safety? Why is this a strategic choice and not just a nice philanthropic choice?
Because of what the source calls the muscle memory argument. For me, this is the most profound part of the entire document.
Break that down for us. Muscle memory for what?
Look, sooner or later, we are going to face a very high-stakes AI safety issue. Maybe it's a rogue model. Maybe it's an AI-enabled biorisk. Maybe it's the first glimpse of AGI alignment going wrong. These are potential existential threats. If the very first time these fierce corporate competitors try to coordinate is during a full-blown crisis at 3 o'clock in the morning when the red phone is ringing, we are dead. It will be chaos. It will fail.
They won't have the emergency phone numbers. They won't have the trust. They won't have the shared protocol.
Love it. But what if they have spent the last 5 years collaborating on global education? What if they have already built the secure communication channels? What if they have already signed joint protocols and worked with the UN and national governments to deploy these $10 phones?
They'll have a history of working together.
They will have muscle memory for cooperation. They will have used global education as a sandbox where they learn how to govern the technology together on a problem where the upside is huge and the downside risk is low.
That is a powerful reframing. It moves the narrative completely away from man versus machine.
Yes.
And suggests the real threat is human institutions failing to coordinate.
The report puts it bluntly in a section titled, "Why Politicians Can't Save Us." The tempo of legislation is just too slow. It takes years to pass a meaningful bill. AI changes in months. The center of gravity for operational safety isn't in Washington or Brussels or Beijing. It's in the labs.
So the builders have to learn to govern themselves. And education is the training ground, the dojo for that self-governance.
It creates what the report calls a civilizational stabilizer. Just think about the narrative. If the most visible, tangible impact of AI over the next decade is that it helped 1 billion people learn to read and enter the modern economy,
The global trust in AI goes up.
the temperature comes way down. It directly counters the dominant narrative that AI is just a tool for the elite to get richer and for corporations to consolidate power.
It aligns the builders of the technology with the long-term interests of humanity. It gives them a social license to operate.
It is the ultimate pivot. We use our most advanced technology to solve our oldest problem, which is ignorance. And in the process of doing that, we teach ourselves how to not destroy the world.
You're turning global education from what most people see as a charity project
Mm-hmm.
into a global security imperative.
Precisely. It's the insurance policy for the entire AI age.
So let's bring it all back to the listener. We've walked through this incredible journey from the broken floor of infrastructure through the language tracks and pilot purgatory and up to this massive, hopeful vision of a trifecta.
Yeah.
We've seen how fixing education might actually be the key to fixing AI governance. What is the one big takeaway here?
I think the biggest takeaway is that we need to stop looking for magic. AI isn't magic, it's infrastructure. And like any infrastructure, it requires this forensic, almost obsessive attention to detail.
To the boring stuff.
To the boring stuff, fixing the power, fixing the fonts, fixing the data costs, fixing the trust with the teacher. It's unglamorous work, but it's the most important work there is.
Reality is more complex than the demo.
That's the line. That's the whole thing in a nutshell. Success happens when you embrace the messiness of the real world and you solve for it, rather than try to pretend it doesn't exist.
And for the industry, for the AI labs themselves, the message seems to be really clear. Compete on the model, but cooperate on the human.
Yes. Build a trifecta not just because it's the right thing to do, but because it actually builds the kind of stable, prosperous world you want to operate in 10 years from now.
I want to leave you with a final thought today, something to really chew on as you go about your week. The source posits that education is the proving ground for our future with AI. So here's the question it leaves us with. If we, as a species, with all our brilliance, our trillions of dollars in capital, and our godlike technology, cannot collaborate enough to simply teach a child to read in a rural village, what hope do we have of collaborating to save ourselves from an existential threat?
That is the question.
Think about that. Thanks for listening to Deep Dive. We'll see you next time.